So we'll continue from creating our missiles this time. We're gonna be shooting random missiles from the center of the ship after certain frames, and we're just gonna let them try to catch our ship. For the moment, we can turn off our impact machine gun or the laser bullets. I think we can create it here. Let's rename this maybe ship guns and missiles. So we will create another node here but before we forget, I guess because these are our random nodes, we should probably drop in a placeholder missile for the PYRO cache to be renderable, so we don't forget. Missiles RS. No, these are not missiles, these are bullet hits. That's gonna be two. One is volume bullets RS, bullet hits, let's call it bullet hits RS, and bullet hits, let's maybe name it to PRT as in particles. And then let's take this guy, copy paste, and this one is going to be our PYRO Sims, so wall, which we will use Redshift instancing. Now we can have a look at the the sourcing for our missile. So let's rename this our, and I think the ship at the back was ship B, ship A. Where is our ship B? No, ship A is our ship that will shoot the missiles. Yes, as in we already put it on the left side. So let's call this ship A missile, and let's go inside and let's object merge our ship A. I'm gonna lock this here, so let's go in our ship A. Where is our transform is here. Okay, we can bring this guy in here. Okay, and let's go back into our ship A missile node, and then we're going to we just need a point actually at the center at the moment, so we can shoot it somewhere from here. So I guess we can create a pack and transfer our velocity. We don't have a velocity here, that's fine. We can put an add swap. We don't need the geometry itself as for the moment, so just delete the geometry but keep the point, and that's going to give us our animated point. We need a velocity for this, so our missiles they know which direction to go to. Change that to compute velocity, and now we're going to drop in a popnet here to shoot off our missiles. So let's call these missiles dot, and let's dive inside. As usual, we are going to copy paste our collision objects from our guns setup, which was in our Gatling laser network. So this part I want to copy. Let's go back in the ship missiles, paste. Okay, drop and merge. Left effects right. I do want to put a gravity here as well. Okay. Well, we could probably do that by pop force, so that's fine. We'll leave it as this. So then we need to decide until when we want to shoot, right? This, because we don't want this to be so random. Maybe a moment of opportunity. That's when our ship shoots. I'm gonna load the city and everything. Just scrap the simulation for a while to decide on when I want it to stop shooting. Maybe we can start shooting here, so our missiles go up and down, and then maybe they have an impact of a few buildings whatsoever. So I want my missiles to stop shooting around frame 240. Frame 240 between maybe, I don't know, shoot like for 50 frames, I guess, from 140 to, as he's diving down, 200. Okay, let's stick to that. So I can go to my bird, and my constant bird rate, I want to give a condition, so it's like almost like 1 missile a frame. So let's start with $F less than 240. Okay, and I'm going to create a pop wrangle now, because I want to create the rule. I want to, if a particle passes, when a particle is lesser than certain age, I want to define that as an active group. So then almost like its fields runs out after a certain age, and so it can crash. So let's start typing by creating a string called group, and that's gonna be active group. Nope, mistype. Active group, semicolon. Okay. Now I want to create a condition called at age less than 10. Okay, this is like an if statement pretty much. It's the short form of if statement. You can find an example of this in the make group from I'll just show it actually. You can use this if you drop in a wrangle. In a wrangle, I think I've said that a few more times before. So like I think what we're using is kind of like color based on point, group based on threshold. You can study this, examine this. The one thing that is really cool is here. I think it will help you for loops to create. This one creates hair, but this is really cool for learning loops in Vex. So have a look at that. So now we want. Sorry, this is the condition, right? Yes. And then I want to say set point group geo self or 0 group at point number. So if the condition is satisfied, make geo self. This could be 0. Okay. So now I want to put a pop force. This pop force is going to be just for randomization along the trajectory of our missiles, but I want this to only work on active group as well, which is not going to be available here because we need the first we need particles that are lesser than 10 frames old here. And then we need to set our start frame to when did we say we're gonna start shooting? Around here. Let's have a look. Again, like 5-6 bullets going. So I guess here, yeah. So we can change the start frame to 135. And let's go inside again. Okay, our collision mesh is here. Our bullets are gonna fire soon. We really want a fast acceleration from our bullet, so let's put this 2. That depends how fast we want missile to separate from the ship. Not really a big deal. Something will change after anyway. So now the important note is here, the pop attract, because that's what's gonna be making our bullets chase the other ship that is in front. And so we will have a goal that is basically the current position of the ship in front. That's where we want our missiles to try to reach. We only want the attraction to work until the age is reach to 10, so they don't follow the ship forever. So within the last scene, the worked values that based on the ship speed and the surrounding geometry was I settled between these values. We will have to play in this scenario because the topology of the layout of the ship, the city has changed. So I think that's it, except now we need to get the goal, and which we are gonna just use a point expression. So how can we get that? That's what we need. We can, this will be our, let's say, source missile, and then we can object merge our target ship in here. Target ship, that's ship B, right? We have that one here. Let's see. I guess there's no group one. Yeah, it's just object merge one, which we can do that. In ship B, I would like to merge my object merge. Okay, so that should give us a proper baked world space coordinates, and these are the values that we want our missiles to chase. So let's put a null here. Out target, okay, and let's dive inside. And now we're gonna say the viewport broke again. Okay, and now we're gonna type point expression, and then we're going to, I wonder if this accepts second input, third input. Not really, no. Surface points, these might work, but it's, I don't think it looks for a point. Yeah, it does actually. I guess we can do that. First context, second context. So goal, I can delete that, I suppose. I want it to follow the second context, which we can try, but I think I tried that and it didn't work. So if I put that here, come on. I think I tried this and it didn't work. I'll just stick to position. Let's keep using the point expression. So okay, we'll put a point expression here. Point, as usual, point to the path as a string to our object we're interested, which was out target. I'm gonna copy this. Do I have one here? Did we get out enough? Yes, out target. And then I'm interested in the position, obviously, of the first point. So that's gonna be so typo there, 0 of the position of the first number of the vector. So that's 700. Let's cross check. So it should be the x is 700, which is it. Yes, that's correct. So let's move forward. And okay, after this tutorial, I'm definitely updating. Where's Puppet Track? Okay, so I'm just gonna copy paste this, and in order to get the y component, we just need to change this 0 at the end to 1. So that's gonna be y, and we'll do the same as RZ. Okay, here we should put a trail swap because the attract force in the DOPNet for particles can predict which direction to go, and which direction is our target going. So we should definitely bring that in as well. And to do that, I can just change this section to V. So instead of position, I'm getting the velocity. So I'm gonna do that again. Y component and Z component. Okay, so that should do the trick. And we want to add some kind of gravity as well. I guess this should give us what we need in terms of bullets chasing each other. Are we shooting anything? That's the part that we need to figure out. And I probably need to see this with much bigger points. Okay, let's see. We're not shooting anything yet. Maybe it's our source side. Yes, our source, our points. So we need to change our source to points. Let's press play again. Okay, they're not really. We're not shooting. Is it bouncing? Oh yeah, it's hitting a building. Boom, 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 boom. Okay, I wonder if, I think we need to be able to tell them to turn around a bit faster. And our missiles are not avoiding buildings, which will give us a bit more chance for maybe creating some explosions. So let's press play again. I think our bullets are firing off a bit too fast, so that could be because our attraction force value is too much. So I'm gonna go for, although we need to make sure that it's definitely faster than the source, which is our ship, so they don't stay behind. I think they are still way too quick. And we can definitely start shooting earlier as well. So I'm just going to increase the rate here. So this is because it's just returning 0 or 1 as a condition. So I'm going to put 2 here, so or even 4. So it should fire more missiles now. Yes, okay, that's kind of working. I want to make sure that I actually have the groups working as well. So active group 10, yes, that's working. For scale, maximum distance, speed scale, maybe our speed is too fast at the moment. We may need to play with some more values. For scale, I'm gonna go 2. I want to look from top. Play with these values until you're satisfied. I think we're shooting too much, and we definitely need to die when we collide. Add hit attribute, so that's, I think, something we need to do. And then we will die when we hit. Okay, so where's our second ship? I want to see if these are okay. I'm going to turn off the buildings because I want to see if my bullets are actually trying to follow the ship. So maybe for scale, I'm gonna put 20. Okay, they're definitely trying to follow the ship. I think, however, I think we're too fast when they shoot. Okay, let's put this to 1.25 again. Let's put this to 15. Okay, I'm gonna look from the flight cam with this turned on, as well as, but we just want the missiles, right? So let's rename this the top object to missile. Okay, and then maybe select the object to missile as well. I just want to make sure that these guys are trying to follow my ship a bit better. Feels like they're not really following that well. Oh, they are kind of, but I think we can make them turn a bit faster. Pop force, I think that's gonna be the scale. And maybe we can say predict intercept. If I press play now, maybe we can shoot a bit less. Okay, if we bring in our ship. Okay, a few goes through some building, a few is kind of going. Remember, these are not smart bullets. I think we can try a crowd tool here that we used for our traffic. Where was it? No, we didn't use it because it was too heavy. Okay, right click, crowd, source trigger. No, it was a crowd source state transition. It was for avoiding collisions, I think. I don't remember, but there's a crowd tool for it. Pop steer, yes. I think pop steer obstacle. Okay, we can try this one. Let's try it. Just we can put in the buildings here, which is this guy. So we can tell maybe bullets to avoid the big building, but this should have an impact on the speed of the sim. And if we put the buildings as well, so they'll still try to reach, but to avoid the buildings. And let's see if that's working. Let's see if they'll try to go around. So far, one didn't made it. Okay, we probably need to. Okay, two made it. I think we need to force them a bit more. I'm not sure how this exactly works, but it works as a pop force. Okay. Maybe we need to go a bigger particle scale. Multiply collision padding. Increase the effective size of the objects can be used to control how close German agents can be. Okay. I guess we can fire avoidance force. 20. I just did, I guess, front search distance 50. And then I guess we need to put something here like 5, completely random numbers. I have no idea. I just want to see the result. See if the bullets are actually avoiding anything. And it doesn't seem to be doing anything so far. Maybe it needs cross the force. Guide. Let's look at the guide. Let's see if it shows something. Collision padding. That's what, I don't know, 1. It's the 5. Front search distance, near avoidance. Force 20. I'm gonna put 200 here to see if it's doing anything at all. So bad. This is the geometry. That's fine. Come on. Avoid the buildings. This guy is always hitting it. This guy. Maybe my collision shape is not good enough. There's no projection. Let's try again. These 3 missiles survive. The others hit the building. I am not sure why. Let's try the crowd steer first to see, but there's not. Maybe pre-solve. Okay, I'm gonna give it a one more chance. Now these bullets are just dumb and they just crash into these buildings. This is, although I'm not sure why this is not working. So collision padding, maybe our values are just not good enough. The node EP scale says of each, okay, oh, maybe because our particles aren't heavy. Letting you allow agent particles to more or less tightly packed. Far avoidance force. Samples, number of frays, yeah, not that. These sample weight bias. Terrain projection option for obstacle avoidance for onto a terrain. No, I don't need that. Yeah, it kind of needs to work, but it's not really working. Let's try it in pre-solve. No, this is still not good enough. But this makes no sense. Okay, I'm gonna open up the documentation. Okay, so I did play with the settings a little bit to get the right look, and the one that helped most was to turn on the guide, and here are my numbers. And if we look from the flight camera, that we can see the guide. So these are each of our missiles being shot from the previous from the ship behind, and it kind of seems to be working. They're roughly avoiding as much as they can, and then based on their ability to turn, they either get exploded or not. And now we're going to use these to create our missile source. So we can get up one level and create a DOP import field here under the DOP network, DOP import field, and we want the DOP network to be our missiles, and then inside the missile DOP, we remember we named the pop object as missile, which means we can just drag and drop the DOP node here, and then put a slash, and I go missile, and just make sure there's no typo, capital M, yes, and this should now we'll be able to fetch the information we need. From the presets, you can select particles. So if I turn on my visibility here, I should see my particles here with their age and some attributes. And what we can do now is to get rid of again of the attributes we don't need. So let's call this import missiles. Okay, and then attribute delete. I think the DOP import also has attributes to delete, but it's the attribute delete kind of gives you a drop down, which is easier to use. But I already have my filter. I'm just gonna paste that. So I just want to delete everything except velocity, ID, life, and age, right? And I just get rid of everything pretty much. And what I want is to also to get the start frame of each particle by subtracting their age from the current frame, which is going to return me the start frame, which tells me when these missiles are fired, right? So I can put an attribute wrangle here. Let's call this clean attributes and calculate start frame or emission frame. So how do I do that? I'm going to write a little expression here. So I'm going to say integer at start frame equals at age times 24, right? Because that's the it's 24 frames per second. That's going to give me this value, but that's not really correct. Now this is actually how many frames it has been living, and then I'm going to subtract that from the frame current frame number, so that's gonna be minus at frame, right? So that's gonna give me some negative value, obviously. But actually, if we go to frame 148, I get my start frame 147, which means if I go to 211, I'm gonna get another 212. So that's like the +1 frame, right? Although this might end up being a float, so we don't want that. So let's convert that to integer. And then I don't want negative values, so I'm gonna convert that to an absolute. Okay, so if I have a look, I have my start frames -1 frame actually. So it's my particle appears at frame 148. So I can just do a +1 here, because at the first frame they don't have a life, right? And now I have my start frames, okay? And now if I go to my last frame, I can just, I know that when I'm going to be able to start my simulation. So let's cache this out. So it's just going to be a simple file cache. These are just a few particles. Let's call these missile caches. Okay. I'm going to change this color to something that I can recognize that this is an important node, or there's some calculation happening here and here. Okay, let's tidy this up a little bit. This I like to use because it gives it nicely shows what is linked to where, if any information exchange is required. And I don't remember where we were saving, so I'm gonna go to ship guns, and maybe this guy can be also blank. So I'm gonna copy this path to make sure that I am consistent with my caching. And yeah, so that's gonna be the missile caches. So just let that cook, which should be quite fast. This starts from 135, but that's fine. So let's cache it out, and it's cached. Load it back. Just a few caches. I don't think yeah, I had that actually. I was thinking if I turned on the my terrain as a collider, but apparently I did, so that's fine. Okay, so now we have the caches. Now what I want is to create a time blend load if I need to interpolate. Okay, so I'm gonna put it here. And then I think we can just leave this as default. I don't think I changed anything. It's just for interpolation if we need to. And I'm gonna put now an attribute node, attribute rename. Not orient, attribute rename. Now I would like to rename my ID of my particles to cluster ID. Okay, and now I want to loop each one of these points in a way that I want to use them as a source. So these are quite small points only, therefore it will not be useful. So we can put a for each loop. We're gonna do like copy stamping, so I think we can do the like for each loop. Where's my for each loop for points? And we can plug in the first guy here. So what I want is to create a little like a spread out, like a cone shape that I'm going to use for sourcing, not just a point. It's basically, I want to create a little shape that I can copy on top of this. It kind of gives the resemblance of a rocket cone, the rocket thruster. So let's put an add swap to copy. So it's just 1 point. Then I want to generate more points from this. So I can say point generate. So I want 5,000 points. Actually, do we need this? Yeah, actually we don't need that, but I don't know why. Maybe this overrides the position. I kind of remember actually. Okay, let's put a copy 2 points. So I want to hook it up like this, right? So each point I want to copy my points. So right now they're all on top of each other, so you can't really tell anything. So what I want to do is my randomization now, so we can put a point swap. So from each point number, I want to create a random value. So I'm going to drop a random point, random swap here. So let's plug the PT num to random, which is going to give me this random number. So now I want to displace each one of these points along a certain normal, which is the velocity. So it's going to kind of like stretch along its axis, right? And so I think if I can already see the result of this if I just shift it like that. But now what's happening is every single point is shifting the equal amount, which I don't want, right? And that's where I'm going to use my random hooked up to amount. But now it's kind of like too much as well, so I want to be able to control that slightly better as well. So then I'm going to put a multiply constant here. This is something that will be something that I don't need to play so much, so I'm just gonna kind of drop this. So you see what I'm trying to do here is that I'm offsetting each one of these points randomly along a certain distance, and I used 0.2, but I think that might be a bit too much in this scenario. It's gonna help us with the stepping issue that we might have when we are emitting from fast points. So then the other thing that I want to is that I don't want these to go straight. So I want to measure the distance from my original position to my updated position, and then use that as a p-scale to use with point jitter, which I will show you now what it means and why. So we can put a distance swap. So we get the current position, the input position before the displacement, and then we get the output position after the displacement, and then we export the distance as p-scale. Now point jitter has one feature which we want to use, point jitter, that it can displace points based on p-scale. So now if where are we looking at? We're looking at, this is the first guy I think. If I use p-scale, it's kind of gonna give me this shape, right? Although it kind of looks the opposite way. I guess we want to turn that around. Let's try it like this. That is going to give us an emission from first to last. Okay, so maybe we need to put minus. Okay, so then if I go outside, each one of my sources is going to have this triangle shape, which is a bit too much now. Of course, we're gonna fix that. And now what I want to do is I want to copy the ID attribute, sorry, cluster ID to each one of these points, right? So attribute copy, that's my left input. What comes from here is my, we had the cluster ID. This is what I want to copy to each one of these newly generated points. So select it, cluster ID. Okay, so I think one of the things that we can export here is the scale, and I suppose we can put a multiply instead of multiply constant, and then export it as well. Let's call this distance mult, paste. Here we have our scale, that's fine, and there's nothing really, isn't anything else. So if I go here now, sorry, my distance multiplier should give me the spread, and the scale should give me the distance, and in point jitter I can then dial down how much spread I want. So if now I look through my flight camera and press play, I should kind of get trails which I can use for a nice source. Although I think it's quite static, so in the seed we can say $F. It's going to give us a bit more changing every frame range scenario. Okay, so that kind of should work. Now what we want is that I want to be able to wedge each one of these sources separately, right? And we're going to use the cluster tool here, which is going to be super handy. So what I want now is I want to put an attribute wrangle again, and this is where we're going to use PDG once again. Let's create a channel. Well, we don't need to create it from the gearbox, which we can do directly from here. So I'm going to write a little if condition if I at cluster ID is not equal to exclamation mark equals is not equal to channel cluster ID, remove point 0 at point number. And if I now click on this guy here, I should get that, and this is supposed to be CHI, I think. Yes, let's do a CHI, so it gives me a slider for integer. We have a little typo here. Okay, so if I now move the slider around, my source should change each based on the cluster ID. Okay, now the other thing that I want to do is probably I want to change my promote my, let's call this actually keep range, keep wedge, and I think I want to change my start frame, because I had a start frame attribute here which should be still here, yes, and as a detail attribute, so I'm going to promote it, attribute promote start frame, which should be here, to detail. Okay, and I can delete the original one, and this is finally now the source for my missile trail. And I'm gonna call it out source. Okay, let's save it now for as number 9 missiles. Okay, now I think at this moment we can go outside and use the shelf tool to do the bidding. Hopefully it should work quite well. So ship missile I'm going to turn on. Let's go a few frames. So that's our guy, right? Maybe turn off a few parts in case we need to do some selection. Where's my environment? Okay. And the thrusters. Okay. Okay, maybe the lights as well. I don't need to see them in the screen. Okay, so let's select now the I guess, I'm not sure, smoke trail. Yes, this is the node, and we're gonna have a look on how this works as well. But if you select it and then click on smoke trail, Houdini is going to basically do a trail, and it's going to create kind of like a source, and then it's going to divide it in chunks, so we can use with these sources as a different container based on the cluster IDs that we have also promoted. So if I now go inside the newly generated node, which is this ship A missile source points, we can reorganize it to see what we're doing. So we'll have a bit better clear understanding on what this tool does. It's actually quite smart, it works quite well, but you can recreate the same thing if you want to do the same thing pretty much. So in the first node, it kind of just imports our wedged source. We probably created the PYRO as well, and it's visible, so it's trying to calculate it. So let's turn that off for now and actually move it to where we want it, which is right under here, and that's our PYRO right under there. And then that's going to be our PYRO import as well, because this is our section for the missile trails. Maybe I can put this in another network. Let's make this red. Let's put this in another network. This is our missile trails. Let's make this maybe, I don't know, yellow. Okay. And all of this, we can give it a different color. But this is what we want to render ultimately. This is our source. This is our original file. Okay. So let's go back inside source points to explain. So it creates a source frame from frame, and it's just doing the a trail here. So if you look at it, we need to put it back on auto. Okay, so where is my source point? Is here. Create. It's kind of failing. It shouldn't have been failing. I failed to cook template. Isn't the wrong frame? Trail length. We have too many frames. Shouldn't fail. Let me see why this is failing. Maybe our restrise values are not too optimized. Okay, let me continue with on manual to see what's going on, because I don't want to go further down. Okay, is there anything else visible? I don't want to cook something else as well. Okay, PYRO import was on, so let's try again to make sure that we have the source. Okay, so this is our source. Okay, and we're gonna create a source frame. Trail sub is, let it cook. It's erroring. Invalid source for each and one error, failed to cook template geometry. Did we not cache it out? Maybe we need to cache it out. It's erroring on loading it out source. We don't have to. Okay, I'm going to have a look into this a bit more detailed in case something is breaking, because I think it's complaining because not finding the correct frame for each and one. Let's try again. No, my Houdini crashed, so I reopened it. This is the part where I crashed it, so I'm just gonna turn off the visibility of all this stuff again. Trying to investigate what went wrong. Okay, we don't need to trust this as well. So last thing we did was, this is I think where it was. So if I scrub, I'm going to have my bullets here that I'm not seeing at the moment. They're too small, but if I make the points bigger again, they were somewhere there. Okay. Okay, so now selecting this, I wanted to create my missile trail, so I click on it, select, and it's erroring again. Okay, let's select it here. I guess let's try again. And it's erroring. It has no attribute, has no prims, because it doesn't need to have a primitive. It should have worked. Because it thinks it's disappearing. Maybe I need another one. at this frame. Okay, this was just working, and I don't know why it's not working now. So I need to investigate it even more. I'll check this now. Clustering, maybe I will save and reopen my scene. Let's try that. Let's see if that's gonna do anything. Okay. Just gonna open a new Houdini to see what is the problem here. It's opening on my other scene, other screen. Okay, let's reopen the scene file and try to see why it's not working. Okay, even if that doesn't work, we're gonna recreate the shuffle by hand. Okay, so here's my cache, those yellow points. Okay, and FEM, where are you? Pyro FX, it's my trail. It's not prims, okay. It's just points. It's erroring here. Oh, okay, so this guy is erroring because it's reporting an error. I guess that might help. So instead of error, I wanted to say that there's no geometry. Okay, so that might be a reason. Let's try again. And now it's okay. So now it's creating something. Okay, we're just gonna let it cook. Okay, so now it gave us this trail, right, like we were doing before. And I was trying to explain you what this is doing, and it wasn't kind of doing it exactly the way I wanted anyway. So we were gonna kind of modify it, but I just want to show you what we are doing here. So it brings in the points of our selected wedge and creates an attribute called source frame equals the frame, which is here, and then it creates a trail swap to create the trail, and was erroring in the previous one because I think it was of the file error because we didn't cache the full frame range. So it kind of creates like a trail of how long, as much as this missile leaves, and then it kind of uses the cluster points to create clusters. So let's say if this is becoming too heavy because the missile is moving too much, you can just do 20, and 20 is going to give us a bit like a shorter, more clusters. So it's calculating, it's going to update, but we don't want that. I think that is fine for now at least. And then what it does is that it transfers the cluster ID onto this range of points. So this one gets like 9, and then so on and so forth. It's changing, as you can see. And in the create density is the part where we are adding our values. So like we have the density and the temperature, and I'm going to leave them as default now. Particle size, I'm going to leave it as default 0.0625. That's fine. And there's the add noise here. I think this is also, I'm leaving it as it is. Don't really need to change anything here. Nothing that's so complex. Although the voxel size is quite important here. That might end up being too big because, so if I go in, I'm gonna put it on manual. I want to change my particle scale to 0.01 here. And I want to keep the normalize on, because the particle scale will create like a really big voxels, and I'm trying to avoid that, and it actually slows down our setup considerably. And I need to now find some particles somewhere here to make sure to see that that's actually doing something. And yes, that's what I want. It was not visible because I was in the wireframe mode. So that's kind of like our source per frame for our missile. So if I want to play with the settings, I can change the particle scale, but it's kind of like slowing it down. We really don't want this to be slow, so I guess we can just go at the end and increase the particle scale. Maybe instead of dividing by 4, let's go divide it by 2. It should give us a bit more scrubbable speed. Oh, okay. So now we have the out density. That's fine. So we also have this other part that is creating these instance sources, and let's see what this does. We don't need to play anything with here. This just kind of keeps the cluster points right in the center, and then it just kind of removes based on if it's not equal to the source frame, which is pretty straightforward. So let's stay on manual, reorganize our missiles here. That's the part that before it crashed. So that's our source. Pull this down. We have to do it again. Sorry about that. This is PYRO import. This is our source. No, this is our output. This is our preparation, our source, and our output. Okay, so this guy was our missile ship guns and their impact. So this is the guns. This is the missiles. Okay. Let's give it a color, right? This one I picked. Let's pick it this time orange. I don't care. This one's green. Sure. So now I'm gonna go to the first frame. I'm gonna make sure that I'm on manual. And so when do we know that our first missile appears is around, so we can use that from here, right? So we don't have to calculate. What we don't really need is frame 154. So we can change our start time for our .NET to 154. And now we can dive inside. And for PYRO, let's select something big for now, like 0.4. And I guess that's pretty much it. And we just should hit press play, and then it should kind of just work. But we need to play with our settings, obviously, like auto resize. I think we can change, because we have quite fast missiles, so we can change the padding to 10 or maybe even more, which we'll need to check. Max bound and distribution stays as it is. Let's go to PYRO Solver. In PYRO Solver, in simulation, I believe I got everything as default. In combustion though, no, combustion is also fine. Sorry, shape. Under the shape, I have dissipation is 0.075, but I have a disturbance of 4. I have a turbulence of 10. Under the disturbance settings, we are at temperature, but I changed my control influence to 2 and control range to 4. If you guys want to know what this means, these are well defined in the help file. If you just press here, it's going to explain. It's basically how we want to control how much disturbance we want to feed in, etc., using these values. So cutoff is 0.5. I'm going to turn off the block size. I want to use the locality as a limit as well. Let's go to turbulence. So my swirl size is 5. I think that's all I've changed here for the disturbance. And if you go to advanced, I think there's nothing in advanced that I changed in my other scene. So let's just press play to see what this is gonna do. So yeah, we are getting a bit too much inherited speed. Remember, we are firing backwards. It's a missile. So I'm gonna go 0.-2 instead of my current direction. So that should kind of like shoot backwards, but I'm getting cut out sections, and that's most likely because either our source is too short, or our padding is not enough, or our substeps is not enough. So to remedy that, we can increase our padding. Let's go, let's try 20. Maybe in this version my sims are my missile is going a bit too fast, but okay, so it's kind of working now. If I press play, Yeah, this seems to be reasonable. If we look from also from the flight cam, so that's one of the missiles. So the only thing that is left now for us to do is to shade it a little bit better, I guess, which we can do from here for the sake of testing. Density as well. So it gives kind of a little bit of a breakdown based on the density. And then if you go to emission, I guess we can use that's the part actually we need to play to make sure that it's working. We cannot change it to something visible. 0.2. No, I think it's just maybe too evenly spread out, but there is no fire at the end of the missile anyway. So what I see there's a problem here is that arrow shape that I think we're spreading a bit too much or just not randomizing it enough, but so that's where we can, but after that it kind of becomes pretty cool. So let me play it a little bit more. So kind of like keep shooting as well, because the thruster after all maybe it's still a bit too much, or we can actually break that up a bit more so it's a bit more random. But for now I think it's going to serve the purpose, and we know how to change it. But the only thing we need to change to make sure it's working is actually changing our source in the keep wedge to make sure that our system is also working. So if I change to another bullet, like one of those, I don't know, that leaves a bit different, longer. So I don't know, let's change it to 4. Okay, 4 starts at this frame, 191. So if we go in now, it's going to recalculate the source points, obviously, because we changed the source. And then if we go into PYRO Sim, press play, hopefully it's going to start spawning containers at the good frame. And it's just going to work. Okay, our resolution, remember, is not very high at the moment. It's only 0.4. But instead of now creating a huge container like this, basically Houdini is creating a container where it needs. These containers do not talk to each other, but it's not gonna be a problem for us at the moment, because this is just gonna be because we are kind of passing through these volumes anyway, so it's just gonna be, I think, pretty fine. We'll never see that edge. Okay, so now what is left is to actually cache this out. I think we can do the same thing that we did to the pyro impact, which was our bake pyro from hit. So I think I can just copy this, honestly, and just rename it after the pyro import in here. So that's what we are importing, right? So I can come in here, and then I can say I would like to, this is gonna be what we want to wedge. So we can do that already, which is our attribute here in the missile. Here, this guy. So if I pull it here, that should, I need to actually attribute, sorry, so I need to pull this here, relative absolute channel reference. So that's how I need to do it. Yeah, and then the name of the attribute is cluster ID. So that's what I'm gonna write here, cluster ID. And we need to see how many missiles we have to figure out how many wedges we need, right? So as far as I can see, we are hitting 8, which means 9. So it's 0 to 9, that will do. I think we need to make sure then also our attribute override is properly linked. So here we were overriding, I'll do this. Here we were overriding keep wedge, keep attribute. So if I go there, this guy, and here I have the @keep sign. Okay, so that's how we connected as well. So that's what I'm gonna do, but this time I think it's not the @keep. Well, it's the, I think we did the same thing anyway. It's gonna be the name of the wedge node here, which is the cluster ID. So I copy that, go back to my source, wedger here, and here I type @cluster ID. Okay, so that's settled as well. I guess we need to set the oh, because the cluster ID changed, now it's simulating. Let's wait for it to cook it, maybe. Now we can see if there's anything cooking. Here it is. So I'm gonna wait until it cooks to 214. Okay, so I'm gonna name my top network bake missiles. Bake missiles. Okay, go inside. So these are wedger, which is working fine. Wedge count is actually 0 to 9, 0 to 8, so it's 9. Cluster ID, yes. So okay, that's correct. That's correct. Partition index is fine. PYRO wedges. Okay, yeah, that's the part that I need to make sure that I'm writing into the correct place, so don't overwrite. So this is from bullet. This is now missiles. We're gonna say it's missiles, and I think I can save and cache that out. And obviously I want to be able to load them as well, but I'm just gonna copy paste this so I can link the output of this to here, which is gonna be missiles volume rs. Okay, and then we're going to be instancing lights to the source of our volumes. Like here, I want to have a point that lights this section, so it kind of gives like this orange light. So now I'm gonna, so I did save. Actually, let me maybe drop the quality of the sim even more, so I can have a little bit of like a fast version of what I need. Okay, so what I'm gonna do now is I'm gonna go into my top network and cache these out, I would assume, to make sure that this is working fine. File save, and I guess we need to make sure that our frame range is fine, which is that we don't want until 600. We can probably find our last missile in here, right? Which is our number 8, and then we can say that, okay, so this disappears, kind of keeps, oh, it goes forever. Okay, so I guess we can simulate until 400. That's fine. Okay, let's turn this off, and I'll go in here again. To prevent this from cooking every time, in case I'm also in auto update mode, I'm going to put a null here to leave the visibility on. Okay, so that's gonna fix the cooking issue. Let's go back in here again. I think this should be fine. Changing it to 450. All the settings should be correct. We can now investigate if it's working fine. As usual, I'm gonna bring my system monitor here, and we're gonna open up the folder to investigate our files, and if they're generated fine, and we are good. Just a second for the folder. Okay, so let's put this always on top as well. Let's save again. And actually I do want to make sure that I'm not using more. No, that's fine. I'm just gonna probably clean up the memory from this scene because we've been running it. So cache manager clean, I guess. Is it gonna give me something? No, I'm gonna close this, reopen it. Should clean up some memory and clean up so much. I guess my other scene is taking a lot of space. Okay, let's reopen the Houdini scene and launch our top network to cache out our volumes. So then we can move on to our final effects for the our tutorial, which is the crash. And I'll close it. And then we're going to do some. We're going to pick a frame to prepare our render scene, so we can apply it to all our cameras, and that will be it. Number 9. Okay, let's load it in. Okay, fingers crossed. Cook selected. And let's open up the task graph. Okay, I'm going to hit pause and oh wait, it's running Wedge 7 at the moment, and it should start writing out files very soon. Okay, since I think because our scheduler is set to 8, it's kind of dividing 30 to 8, and then it will try to be, which is 24, right? No, so it's kind of, I think it's gonna run 3 sims at the same time. I hope I'm not gonna hit the memory limit, but that should be fine. Yeah, because that's 3.75, right? Oh, but that's a lot of errors. Okay, so let's see what happened. Task info. Why are we failing? That shouldn't have failed. It's just a sim. Is it because it's failing to load the sources? It's not really returning any error. Oh, maybe under here. Cook error, out PYRO, cold after throwing an instance runtime error. Mutex. Setting parameter. It's not a license issue. It's attempted operation failed. Cook error in input, out PYRO. I need more information actually. Okay, let's kill our cook. Delete all results from dirty all. Delete all results, and it's keep trying to calculate miserably, but it's failing. Okay, let's double check our scene again. We are, so that's fine. This, I know that works because it changes the values here, which ends up changing our source here, which doesn't fail because it shouldn't fail because this is set to no geometry. If the error if it's a missing geo, it should be fine. It's loading. I wonder if it needs to be hard coded because it's loading. No, it should be fine. I'm going to investigate from the other scene, and then we're going to get back to it. Okay, I was rushing, obviously. It was a bit of a stupid mistake, I hope. We did, because we copy pasted this, and then we did update our wedger to wedge what, but we didn't update what to pull in. And then out PYRO obviously is not out PYRO here anymore unless we give it a name, which we should, because what we did in the previous shot was to optimize our incoming PYRO from the .NET, so we should still do the same thing. And I am going to do the exact same thing here, which we did for the explosion. So I'm just gonna copy paste that actually, but just to refresh our memories, I'm gonna explain what we're doing here. So I guess, but in this case might be a little bit different because we have quite many of containers. So I guess, come on, I'm gonna test it out on hopefully if I can pause it. Okay, let's let it cook. And scene graph. Okay, so we have, I'm just gonna wait for another container. Okay, so what are we doing here? I think I am looping, we were looping, but then in that one it was different. So here is the problem, right? It's going to get rid of what we don't need. So I'm gonna remove this for now. And let me see if that does it properly, because we are doing it for each primitive, I guess. Yeah, we're doing it for each primitive, so it should be fine based on each top object, right? So that's gonna go over density, velocity, temperature, everything we need or we don't need. But there's also the other thing, is that I am not interested in CD, fuel, heat, temperature, rest, whatsoever. These are just, I need the velocity for motion blur. And then if I look here in this frame, I have 15 megabytes. So then I'm going to, like we were doing before, we're looping based on our DOP object name. So it kind of like brings in PyroSim2, and then it's going to half the velocity field, create a little blurry field around it, and I use that to compress the density as well. And basically here we are 3 megabytes and here we are 200 kilobytes. So if I come here versus add from the same 15 gig at the end, same thing, 1 megabyte, slightly over. It might cause some issues again, like we spoke before, but that's where we're going to create our, that's where we can play with our settings to make sure that it's not that low quality. But that is kind of doing it good. And then the other thing is, because there's nothing uncompilable here, so we just made a compile. So it kind of does it even faster. Okay. So that should do the trick. And finally, our name was, we'll call this, maybe I'll put a null out PYRO. And finally, if we go here to PYRO wedges, we'll call it missile wedges. Give it a bit more reasonable name, and this should now point to the proper path, and I believe it's not going to break now. I'm going to save again, bring in our folder, it's empty, right? Yes. And bring in our resources and save again, right click, just to double check our frame range is correct, our wedger is correct, frame range all good, all frames in one batch. Okay, run through the time, cook. Let's see now what's gonna happen. Hopefully it's gonna be fine. Okay, version 1 folder created, Red 7 is created. soon we should see the frames popping in. And if it does, I'm going to pause the video and we will continue in the next file. And yes, we have some files coming in. Do we have some size going up? Yes. For example, this missile starts at 154, but then it actually starts emitting geometry, emitting data at 0238. So that's good. And I'm just gonna leave this now as it is. So we'll come back once the simulations are finished. Okay, so that actually went quite fast, but because our resolution was not good, it was quite high. So let's observe our final result. So I'm going to drop in a file merge node. Let's maybe bring this in here. Load caches. This was our path here. So I'm going to copy this. Pretty much I just have to change the each index with $slice because that's how the file merge node works. So 0 to I had 9, 10 wedges, just no error. So if I turn this on, it should it should start loading our caches. So if we look from top, so we need to investigate certain things because it was like our pretty much first pass, which went quite fast, so on and so forth. I think this lines are from my viewport issues, which hopefully I'm gonna fix soon. So let me look from the camera and let's press play. They are really small in size at the moment, so they should just kind of work fine. And these are gonna be our missiles. Okay, I see some problems already. But as you guys can see, it's actually kind of working pretty well, but I'm seeing some container issues here and there. That's mostly because our auto resize is probably too aggressive, and we need to fix that. Obviously, as you guys can see here, it's kind of working, however. So I'm gonna stop this video, but before we stop it, maybe just let's change certain settings. So I know that we have a bit more higher quality volume, so maybe subtract the bounce to something like less, field cutoff to something like less. I think we can increase the padding to even like 40. I think that should do it in my case, and hopefully something a bit more reasonable in terms of quality. Okay, so once this caching is also finished, now we're gonna set up the renders of these missiles, so we can move on to our little bit of destruction, bus destruction, space sci-fi bus destruction scene, and hopefully that will be concluding our lesson before we actually set up our render layers. So we'll be just in Redshift and a bit of Mantra maybe. Okay, thank you for watching again.